Hello students, welcome to Chem Expert classes. I hope you all are doing amazing. Today I have brought a session on IUPAC nomenclature for you all. This is the first video on this topic. We are going to start with the basics, and in the upcoming classes we are going to cover the other concepts of the nomenclature. That is, we are also going to cover functional groups, different types of functional groups in the other videos. This video is for clearing the basics of the nomenclature. In this one we are going to cover nomenclature of alkanes, alkenes, alkynes with the branch concepts, the multi-branch concepts, and then after that we will be covering the cyclic compounds as well. So please watch this video very carefully. Now let's get started with the video. Coming to the nomenclature of alkanes, alkenes and alkynes in general. Now if we talk about how do we identify the alkanes, alkenes and alkynes. So alkanes are the saturated carbon compounds or saturated hydrocarbons having single bonds between the carbon atoms, right? That means two carbons are joined together by a single bond between them. There's only a single bond. Now alkenes on the other hand have double bond in at least one of the, two carbon atoms. At least two carbon atoms must have double bonds between them. And alkynes will be having triple bonds, right, between at least two carbon atoms. Alright, so this is the normal concept which everybody should know before starting with the IUPAC nomenclature. That is, alkanes have single bonds, all single bond. Alkenes have at least one double bond, and alkynes are going to have at least one triple bond between two carbon atoms. Now let's just get started with the nomenclature. Now we are starting off with the simple straight chain nomenclature, right? That means a simple carbon chain will be given to you, and then you have to identify the carbon chain and you have to name it, right? So what you are going to identify is whether the given carbon chain is an alkane chain, it is an alkene chain or an alkyne chain. This you first have to identify, and accordingly you have to name the chain, right? Now here I have given some of the hydrocarbons prefix to you. Now before moving to the prefix part, let me tell you what a prefix is and what a suffix is, right? So prefix, as the name suggests, is the one which comes first when you name a compound, and the suffix comes later, and the prefix and suffix will give you the name of the carbon compound. I hope this is clear to all of you. Now, when you name the carbon compound, you have to keep in mind two different things. First is the number of carbon atoms present, and then is the saturation or unsaturation. That means you have to see whether the carbon compound is a saturated carbon compound or unsaturated carbon compound. Saturated means alkane, unsaturated means alkenes or alkynes. Right? Now depending upon these two things you are going to name it, right? So first, the rule here says that you have to write a root name first and then the primary suffix. Now what is the root name? Root name is depending upon the number of carbon atoms present in a compound, you have to give root name. Here is the list of the root names. Now imagine if you have one carbon atom only, then you're going to use the root name meth. If you have two carbon atoms joined together, then you are going to use eth. If you have three, you are going to use prop. 4 bute, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, and 10 tec. So depending upon the number of carbon atom in your chain, you are going to give the root names, okay, also known as prefix. Then what you're going to do is you're going to use the suffix depending upon whether the carbon compound given to you is an alkane, alkene or alkyne. Now imagine you have a carbon chain of 3 carbons, and you can see over here that all the carbons have single bonds. That means The chain is an alkane chain. So what you're going to do is you're going to use the prefix from here, from this table, and the suffix from here, right? So what will happen, for 3 carbon atom, you have the prefix called prop. So you're going to use prop. First letter is always capital. So prop plus you're going to use the suffix which is in continuation. So now the carbon chain is named as propane. So this is how the naming is done. Now if it would have been CH3 CH double bond CH2, then what would have happened? Now the naming would have changed to, how many carbon atoms are there? 1, 2, 3, still prop, plus it is now going to be ENE because it is having a double bond which is alkene, right? So it is going to be now propene, right? Now I hope this is clear to all of you. Let us do some more examples in order to make this more clear to you. Here is our first example, which is this one. Now first we have to count the number of carbon atoms present. So here it is 1, 2, 3, 4. Now 1, 2, 3, 4, we have 4 carbon atoms. So it is going to be bute, right? It is going to be bute. Root word is bute. Now we have to see that all the carbon atoms are having single bonds between them. So it is going to be ANE. The suffix is ANE and hence the name is butane. Here to the next example, here we can see 1, 2, 3, 4, 5, 6. We have 6 carbon atoms. So it is going to be hex. But we have 1 double bond. So it is going to be ene. So this chain is hexene chain. To the third example, 1, 2, 3, 4, 5. We have 5. So we have pent and we have ine. So it is pentyne carbon chain. So this is a very simple thing that you have to remember, the root name and also the suffix which you have to use, and then you will be done. Okay, now coming to these are the very simple examples that you did. But what happens when the position of the bond is changed? That means, see here, if you see, the bond is at the terminal position. That means at the end of the chain. Here also the bond is at the end of the chain. So that does not necessarily change the naming, right? But what happens if the position of the bond is changed? Then the naming also varies a little bit, right? Now what is one thing that you have to remember in that case is, now if you see here in this example, you can see that the double bond is present in the middle, right? The double bond is present in the middle. Now in this case, the rule changes a little bit, just a little bit. That is, the root name and the prefix is the same, but you have to also write the position of the double bond in between. All right. So the root name plus the position and then the suffix. Now what is the position? What is this position about? This position is the position of the different bond or the double bond or the triple bond, right? So anything else apart from this remains the same, right? Now for this we have to do the naming of the carbons first. Now for the naming, we always start with the terminal carbon. Here carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5 and carbon number 6, right? So we have 6 carbon, hence it is an hex, right? Now if we start naming it from the other side, 1, 2, 3, 4, 5, 6, right? Now the naming can be done, or the numbering of the carbons can be done from either of the sides in this case, because if we start from here to here, right, the double bond position is 3, right? Also, if we move from here to here, the position of the double bond still remains the same, that is 3, correct? So that is not a problem. From both the sides, we are going to get 3 position for the double bond, or the third position for the double bond, right? So we can name it or number it from either sides. Now what happens is, because we have 6 carbon, it is going to be hex, and then we put a slash and we write the position. We write the position, that is 3, and then we put a slash again and then we write hexene, hex3ene. That means it is a carbon chain with 6 carbons. On third position, we have unsaturation. So it is going to be hex3ene. I hope you understood this. If you didn't, please put your comments. I will surely make you understand this again. Alright. Now coming to the next example, let's make it even more clear to you. Now coming to this example, here as you can see, you have a carbon chain and you have unsaturation here. Right. Now there are two ways of numbering the carbon chain. Right. One way is you give this carbon 1, this 2, 3, 4, 5, 6 and 7. Or you can number it in this manner: 1, 2, 3, 4, 5, 6, 7. Right. Now first you have to identify which of the numbering is correct. Is it the lower one from here to here or the upper one from here to here? So now as I've already told you, the unsaturation must get the lowest number, right? Here you can see the smallest number to the double or the triple bond must be given when the position of the double bond or the triple bond is not the terminal one, right? If it is a terminal one, then it is not an issue because it is always going to get first number, right? Now here you can see from above, if we start naming, right, numbering, then what will happen? The triple bond is getting position 5, which is higher of course, and if we number it from this side, then it is going to get second number. So we are definitely going to go ahead with this. Now again the same thing, we are first going to use the root word, which is hept for 7 carbons, then slash, then 2, that is the position of the triple bond because it is attached to carbon number 2, and then slash again, and then ine, which is the primary suffix for alkynes. So the carbon chain is named as hept2ine. I hope it is clear to you. Now coming to the branching, different types of branching of the carbon chain. Now here the examples that we have studied so far did not have any branching. Now what is meant by branching is, see here you can see there is only one straight chain and you clearly just numbered the chain and you wrote the name of the particular hydrocarbon chain. But imagine if you have here also one carbon is attached, right? Now this is considered as a branch. That means it is not a part of the longest chain, right? So the branching name is done in another way. Now let us just start with the branching concept. Here as you can see, I have explained the concept for branching. Now there are some rules or the steps which you have to follow, right? So the first step is you have to identify the longest carbon chain. Very, very important. You have to first identify the longest chain. Then you have to identify the branch. And with the branch, you always use this method where for naming the branch, you use the root word that is same for the normal branch, normal carbon chain plus YL. All right. You do not use the primary suffix that was used for alkanes, alkenes or alkynes, but you use IL, YL, right, for branch. Now, what you have to do is same thing that we were doing, root word plus suffix. But before that, you have to write the position of the branch plus the name of the branch, then the root word and then the suffix. Alright. So this you have to remember. First the position of the branch, then the name of the branch, then with IL, of course, with IL, then the root word of the carbon chain and then the suffix of the carbon chain. Right. Now coming to the example, this will make it more clear to you. Now coming to this, now first is the identification of the longest carbon chain. Now if we look here, now we can start counting 1, 2, 3, 4, 5, 6, 7, 8. We have 8 carbon chains which are directly connected to each other. So this can be one of the chains. Then 1, 2, 3, 4, 5, 6, 7. This can also be a part, but then this one is the 7-membered carbon chain, whereas this one is the 8-membered carbon chain, right? Clearly, then the longest chain is of course 8-membered carbon chain, correct? So this is our longest straight chain, right? Now what we are going to do is we are going to start naming, right, or numbering the carbon. So 1, 2, 3, 4, 5, 6, 7, 8. So here you can see 1, 2, 3, 4, 5, 6, 7, 8. So it is an oct chain, right? Oct. Now this is our branch, correct? This is our branch. So it is eth. So branch is ethyl, of course, and the carbon total longest chain is 8-membered carbon chain. Now if you look at the numbering here, the branching is getting 5th number. But if we start numbering from the lower side, that is 1, 2, 3, 4, 5, 6, 7, 8, then the branch is going to get number 4. So obviously we are going to opt for this numbering because we have to give lowest number to the branching, right? Now coming to this rule where you first have to write the position of the branch, which is 4, then you put a slash, then the name of the branch, which is eth, then the prefix il, suffix il, then what you do is you have to write the root word, which is oct, then ane, right? So this is the name, which is 4-ethyl octane. Simple. Now coming to the next example, we will do this little faster. Now coming to this thing here, you can see you have the longest chain. Now you have to first identify the longest chain, which is this. We can see clearly 1, 2, 3, 4, 5. If we opt for this 1, 2, 3, 4, if we opt for this 1, 2, 3, 4, then this is our longest chain, which is correct. Now coming to the naming, we can numbering, we can number it as 1, 2, 3, 4, 5. And if we number from here 1, 2, 3, 4, 5. Now if we look at this, the upper numbering, then what happens over here is the carbon, the branch is getting number 3 if we go by the upper method, and the double bond is getting the number 5. The combination is 3 and 5. Now if we go by the lower number, the branch is still getting number 3, but the double bond is getting number 1. Right? So in this case, what we do is we just add up these numbers. So 3 plus 5 gives 8 and 3 plus 1 gives 4. So clearly 4 is the lower number. So we are going to go with this numbering system, that is the lower one, right? So now again, carbon number, first the position of the branch, which is 3, then the name of the branch, methyl, because there is only one carbon, methyl, and then you have to number the chain, which is 5, that is pent, then the suffix, which is ene, clearly because there is one double bond present. So it is going to be 3-methyl pentene. I hope the branching is clear to you. Now coming to the multi-branching system, wherein you have different branches. Here in both the examples, as you can see, in the first example there was only one branch, which was an ethyl branch, and the below one you had only one branch, that was methyl branch. Now there can be some cases where you have 2 different branches or 3 different branches. That means multi-branches. Then what you have to do is, how you are going to do the nomenclature of those kind of compounds are what we are going to discuss over here. Right? Now coming to those kind of concepts, as you can see over here is the multi-branches system. This is going to be exactly the same. There's nothing going to be changed. That is, you first have to write the position of the branch, then you have to write the name of the branch with il, then you have to write the position of the other branch with the name of the other branch, then the root word, and then the suffix for the root word. Okay, so everything is just the same. It's just that you have to write both the branches first and then the root name and then the suffix. Now first we are going to identify the largest or the longest carbon chain, which can be this one, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Right, so we can opt for this because this seems the longest to me. There are 6 carbons. Right, now we are going to start numbering. So 1, 2, 3, 4, 5, 6. Clearly this numbering is perfect, because if we number from this side, then this is going to get 4. So that is not correct, right? So we are going to go with the this numbering. Now again we will start with the branching, where we have two branches. One is this and second one is this. Now which branch are we supposed to write first? So here is the trick. You have to go by alphabetical order, right? You have to opt for alphabetical order. Now you have a methyl branch and you have an ethyl branch, right? So alphabetically E comes before M. So you are going to write E first and then the M. That means ethyl is going to be written first and then the methyl. Okay, so what is going to happen is you are going to write this as 4-ethyl slash 3-ethyl. This is not the correct numbering. 3-ethyl 3-methyl hexane. Alright, this is the correct nomenclature. Now coming to the another example, a little complicated than the other one. Here, first you have to identify the longest carbon chain, right? So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So clearly we can see over here, this is the longest carbon chain. You can pause the video and try solving the question by your own, and you can then check later whether your answer was correct or not, right? Okay, please comment down. Please pause the video, start doing the question, and then come to the video again and see if your answer was correct or not. And please comment down if you get the correct answer. If you don't, then also please comment down. I will be more than happy to read your answers. Alright, chalo. Now let's just solve this. So 1, 2, 3, 4, 5, 6, 7. 7 carbon stands for hept. Alright, so the root word is hept. Now coming to the branching, there are 3 branches. 1, 2 and 3. And as you can see, all 3 are the methyl branches. Now let us just start numbering. So suppose we start from here. 1, 2, 3, 4, 5, 6 and 7. Then the branch gets position number 2. This group is getting position number 2. Then the other one is getting 4. Then the other one is getting 5. Now if we start numbering from here, 1, 2, 3, 4, 5, 6, 7. Then the first one gets 3. Then the other one gets 4 and then gets 6. So clearly this one is the preferred one because the sum will be lower. So this is going to be 11 and this is going to be 13, right? So we will use the first numbering system. This is 1, 2, 3, 4, 5, 6 and 7, right? Now we will start naming it. So as we have all 3 methyl groups, then we can write the position in one go, right? That means we can write 2, 4, 5 trimethyl heptane, right? Because the branch is the same branch, the branch is the same branch. That is why we can write it together, and we can use tri, and we can write all the positions together to 2, 4, 5 trimethyl heptane. Similarly, if you have an alkyne chain or alkene chain, then again you can do the same thing. Instead of heptane, it will be heptene. Or if the position of the double bond is different, then you can also write the position of the double bond before writing this suffix, right? So this is just pretty much it. I hope this thing is clear to you. Now we have discussed so far the multi-branches, normal branches, saturated carbon compounds, unsaturated carbon compounds, and all of these things. Now last thing which you are going to discuss in this particular video are the naming of the cyclic compounds. Extremely important, and by this we will finish it. Okay. Now coming to the cyclic compound naming. Here it is very simple. There is only one thing which you have to remember over here is this rule. Okay, so what you have to do is there is a particular prefix that you use for naming the cyclic compounds. Now first thing, what are cyclic compounds? Cyclic compounds are those compounds in which one carbon atom is connected to the another carbon atom in such a way that the cycle ends, or they make a cycle. What I mean to say over here is, suppose you have a carbon atom here, and then the another carbon, then the another carbon, then the another carbon. If I join these two carbon together, then it is going to make a cyclic compound, because there is a cycle between the different carbon atoms. Right? Now, coming to the naming. So first, there is a particular suffix or prefix which you always have to use for cyclic compounds, which is cyclo. Right? This you have to always this you have to always use when you name the cyclic compounds. So first you will use cyclo, then same, the root word and then the suffix. That's about it. Right? So first we will start with the simplest compound, which is this one. So here you can see these are all single bonds and the edges show you the carbon atoms. Right? So these edges are showing you the carbon atoms and these are showing you the bonds. Now here we can also write it as this. See. So H2, H2, H2. Right? So it is just pretty much same. Okay, now how are you going to name it? So first you can start with the numbering 1, 2, 3, right? So there are 3 carbon atoms. So first you're going to use the prefix cyclo, then 3 carbon atoms, prop, and then it is saturated. So ANE, propane. So cyclopropane is the name of this one. Okay, now coming to the another example, a little bit tricky. So first you have to count the number of carbon atoms. 1, 2, 3, 4, 5. So there are 5. So the root word is pent, and there is 1 unsaturation in. So you are going to be using pente, right? And before that you will just use the word cyclo. So cyclopentene, right? Now coming to the last example, very important. With this we will end our video. Right? Now coming to the very last example of this video is this one. Right? Now let's just start naming it. Now first you can see there is a cyclic chain. Right? So there is a cyclic chain. And then you have the branch, right? This is the branch given to you. There is a cyclic chain and then there is a branch. Now what you're going to do is you're going to just name or number the branch first. So 1, 2, 3, 4, 5 and 6. So it is hex, right? And now we are going to also see the branch. Now branch has 1 and 2 carbons. So the branch is obviously ethyl, right? So what you are going to do is same how we did for branches. First the position of the branch, which is 1 of course, and then we will use prefix, which is cyclo, then we will use the root word, which is hex, and then we will use suffix, which is N, because the cycle is saturated, right? So 1 ethyl cyclohexane, right? You can obviously avoid writing 1 because if we do not write 1, then also it indicates clearly that the position of the branch chain is 1, right? So it is ethyl cyclohexane. Clear? So I hope all of these compound namings are clear to you. If you have any kind of doubt in any kind of question, then you can please put it in the comment section. In the next class, I will be discussing the nomenclature of the functional groups with you, right? We will be starting with the halogens and the alcohols. In the another video, we will start with the ketones and then the esters and then the amines and then the acids and so on and so forth. So this is going to be a long series, right? Now please practice all these questions and let me know how you understood it. Thank you so much. Please be safe. Take care.